So basically, today we will be going over area, perimeter, and circles. So yeah. So this is today's schedule. So basically, we'll be going over area, so formulas, equilateral triangles, regular polygons, and abnormal shapes. And then for perimeter, we'll be going over formulas and circumference. And then we'll be going over AMC problems. And if we have time, we'll do a fun activity. So area. So area is simply the amount of space that a shape takes up, and it can be expressed in square units, where the units are inches, feet, etc. And most shapes have a pretty straightforward formula. For example, the area of a square is just the base squared, or one of the side lengths squared. So we're gonna take a look into the formulas for the area. So you can, okay, so for the first one, you can see that that is a rhombus. And the area of a rhombus is half of the diagonals multiplied together. And this is because in a rhombus, in a parallelogram, in a rhombus, when the diagonals meet, right, they form 4 right angles. And basically, this means that there are 4 triangles of equal area, right? And the area of a triangle is just base times height divided by 2. So the base of each of these little triangles will be half of the diagonal length, right? So half of one diagonal times half of the other diagonal multiplied by 4, half of this diagonal multiplied by half of this diagonal multiplied by 1/2 multiplied by 4 would be 1/2 the diagonals multiplied together. Then the area of a triangle is 1/2 base times height. I'm pretty sure you all should know this. And basically it's because it's always going to be half the area of a rectangle. And over here, down here, we can see the area of a rectangle is just length times width. And that is also pretty straightforward. If you divide it into a grid, then you will get length times width is the rectangle's area. Then for a parallelogram, the area is just base times height because it's if you cut off this section and you put it here, it will always form a rectangle with the same dimensions as the base times the height. Okay, and by the way, it was the area for rhombus and not the area for parallelogram that was talked about first, just to make sure no one has any confusion. The first one was a rhombus, not a parallelogram. Okay, now for the area of a square, it's just, a rhombus is just the sides are equal. So it will be a parallelogram, however, it will have equal sides. So basically, for the next ones, it's a square. It has the area of the side squared because it's basically just a rectangle with both sides equal. So it'll just be side times side, which is side squared. Then for a trapezoid, it's the average of the bases multiplied by the height. So the reason it's the average of the bases is because if you chop this little piece off here, this triangle on the right, or the triangle on the left, and you put it to the other side, you'll get a rectangle whose side length is the height, and whose other side length is the average of the 2 bases. And that is why. And then the area of the circle, it's very hard to explain how we get it, and there are lots of proofs online, and I should post it in the Google Classroom, like some of the proofs that are easy to understand. But basically, it's pi r squared, and pi is a constant over here. It's approximately 3.141592653, and so on. And then the area of the sector of the circle, which is basically just a portion of the circle, is whatever fraction of the circle it is multiplied by pi r squared. So over here you see theta divided by 360 degrees. So theta is just the angle measure because 360 degrees is what makes a full circle. So the angle measure, the inside angle measure divided by 360 will just be what fraction of the circle this is. So whatever fraction of the circle this is multiplied by the area of the circle itself will be the area of the sector of the circle.
So what you're saying for the sector of a circle is the tiny angle, the angle, you will divide that by 360 and then do pi r squared, right?
Right.
Okay,
And
but
stated, yeah,
wouldn't the like angle always be like lower than 360?
Yeah, that will be what fraction of the circle it is. So for example, say that this is, I'm getting a bit of echo. Okay, so say that this is, that the angle measure over here is 270 degrees. So that would just be 3/4 of the circle as we would see. So basically I'll draw. So this would be what 360 degrees would be. It would be from here to here, right? And it would just be this whole thing, right? So you can visually see that it's 3/4 of a circle, right? So you can do 3/4 times pi r squared. But if you actually find the angle measure, which is 270, and divide it by 360, and note that this is in degrees, 270 divided by 360, and then you multiply it by the area of the whole circle of the circle, if it would be the whole thing, then you get 3/4 multiplied by the area of the circle if this degree measure was 360 degrees.
Okay, and just one more question. How would you find the angle? Like, I get you could, for a right angle, you could find that it's 90 degrees. But for anything else?
So usually if they ask you to find the area of a sector of the circle, you will be given an angle measure, or it'll be something like, a right triangle is able to be like perfectly put in this. So that'll tell you that the right angle, it's like, it'll be like a right angle has its legs on the end radiuses or radii, right? And basically what that'll tell you is that the 90-degree angle is the angle measure. And they'll usually give it to you, whether it's like directly or indirectly, but they'll always give it to you.
Okay.
Yeah. Does anyone else have any questions? Okay. If not, then, okay, no questions. And remember, so because this class is really small, like right now, the people in attendance is really small. I feel free to ask any questions. It's not like it's gonna impede the class or something. Like, you just ask any questions you have. Okay, so basically we will be having a Jamboard to review, and we will be doing these problems together. So basically, I shall give you the link to the Jamboard in the chat. Okay. Here's the Jamboard link. Oh, okay. So basically, find the area of these, and please don't like scribble on the board or something. That'll be very annoying. But basically, so do not go ahead of what slide we're on. So for this first question, find the area of the trapezoid. So find the area of the trapezoid, and yeah. And note that the bases in a trapezoid are the parallel sides to one another. So on a sticky note, so this thing over here, take it and then write your answer. And then put it on the screen, and then it should be here. So like this. And you guys should be able to edit, are you?
Yeah, we can edit.
Okay. Okay, so make sure okay, so everybody should be on this Jamboard. There are 7 of you, I think, in this, sorry, there are 9 of you or 8 of you in this class right now. So please make sure you put your answer. Okay, and remember that the area of a trapezoid is it's the average of the bases multiplied by the height. So that would be half of the sum of the bases times the height. So I will wait until 9:45 for people to answer. And make sure you aren't going ahead, please. That'll be great if you aren't. Okay. So far, I only see 2 answers. So please put, so everyone, please put your answers. I get if you guys are still like doing the math. However, make sure whenever you get the answer to the problem, you are putting it in the chat, or not in the chat, on the Jamboard. Okay, so I see 4 answers. Everyone else, so there are 3, 4, 5 of you, 6, 7 of you. Please, please, please put your answer. So I see 5 answers. 2 more people should be giving their answers. Yeah, please put your answers. The quicker people put their answers, the quicker we'll be able to review each problem. And that means we can get to more AMC problems, so you guys can get better at this. So please, please, please put your answers. 1, 2, 3, 4, 5, 6 answers. Okay. To that person who did not answer, disappointment. But yeah, so basically, you find the average of the bases, which is 10 plus 5, which is 15. Okay, that is not going to work, so I shall use this. Okay, so you find the average of the bases. You're gonna have to look at my screen because I'm annotating on my screen, not on the Jamboard. So you find the average of the bases, which is 10 plus 5 over 2, and then you multiply this by the height, which is 10. So basically, you can either do you can do 7.5 times 10, or you can find out that 10 over 2 is 5, and then you can do 10 plus 5 times 5, and either way, you'll get an answer of 75. So everyone except one person who corrected the answer got it correct, so good job. So yeah, you guys shall get a gold star. Okay, so the next slide. So there are 2 problems on this slide. So it's find the area of this triangle and find the area of this rectangle. So all the dimensions are given, and just a note, the 7 millimeters refers to this part that I have kind of highlighted in blue, and then this green part is the 3 millimeters. Okay, so I see 1 person so far has answered both questions. I'm assuming it's the same person, but make sure that you are answering. The quicker you answer, the quicker we'll be able to do AMC problems, and the more AMC problems you do, the better you're going to be. And there are like 25 AMC problems, so it will take some time to get through them. So yeah, make sure to either label your answers or put your answers on the right half, like on the proper half of the screen. That would be great. Yeah. So I see 3 answers for both sides. Make sure you're not just copying people, but you're actually doing the math, because that'll be kind of disappointing if you aren't actually doing the math. And we covered what you need to know to do the math. So, yeah. Okay. Ooh. Yeah. Make sure you label which answer is which. Okay. So I see 4 answers for one side, 5 answers for another. Okay, yeah, I see 5 answers on both sides. There are 6 people here. There are 7 people here. 6 of them on the Jamboard. This is kind of disappointing if one of you isn't on the Jamboard. So yeah, make sure you're on the Jamboard. And make sure you're answering the questions because, yeah, this is here to help you. Okay, so I see 5 answers on both sides. 3 minutes have passed. You all should have been able to solve this because these are relatively well-known formulas for area. So basically, the base of this would just be 7 plus 3, right? 7 plus 3 is 10, right? So we just do, okay. So we do 10 multiplied by the height. 10 multiplied by 6 is 60, right? So we get 60, and then we have to divide that by 3. So we get 30 as our final answer. So you all got it right on the left side. Now let's see for the right side. It's just the base times the height. 3 times 8 is 24. So again, everyone got it correct. Good job. You guys get gold stars. Okay, so next thing, this is a rhombus. And over here, you can see that this has that the diagonal lengths are given. Make sure you're on this slide right now. I see 2 people are still on the previous slide. Yeah, make sure you're putting your sticky notes on this thing to show your answers. And make sure that you realize that 4 is not the length of the whole diagonal, and 5 is not the length of the whole diagonal, but 5 and 4 are both half the lengths of their respective diagonals. So far I see 4 answers. There are 6 of you. Again, please answer, otherwise disappointment, we don't want that. Okay, so there are 5 answers so far. 1 person has not answered. Make sure you're answering. That would be great if you would answer, everyone. Okay, there are 1, 2, 3, 4, 5, 6 answers. Okay, so basically what we have to do is the diagonal times the diagonal divided by 2. So the diagonal is 8, and the other diagonal is 10, right? And 8 times 10 is 80. And then we have to do 80 over 2. So we do 80 divided by 2, if I can write, and we get 40. So again, I see someone got the answer of 10. Remember that the 4 and the 5 were not the diagonals, but half the diagonals. So yeah, but you all pretty much got it right. Like everyone pretty much got it right. So you guys get a gold star. If I can draw. Okay. Okay, now the next problem. This is just the area of a circle. So if the diameter is 16, what is the area of this circle? Remember, diameter is different from radius. Radius is half of the diameter, and yeah. Okay. I see 3 people are on the previous slide. Make sure you're on the right side. It's slide 4. Yeah. Anonymous dolphin, you're on the wrong slide. Yeah, you're on the right slide. Okay, so 2 people got 64. Yeah, it would be great if you could put your name underneath your actual answer, so like I know who's answering, and if Okay, you don't have to use 3.14. You can just write pi because otherwise you're going to get an approximate answer. And right now we aren't focusing on pi. And also in normal answers, they're going to give you like x pi. So for example, they'll give you like 10 pi as the answer or like 5 pi as the answer or something like that, right? You know, they won't tell you to use 3.9. Okay, so I see 3 answers from 3 different people. Make sure you're putting your answer on the Jamboard. You know, if you are not doing the math, that'll be bad. Okay, so I see 4 answers. Remember to solve the problem and be engaged. So 1, 2, 3, 4, 5. Yeah, 6 answers. Okay, 1, 2, 3, 4, 5, 6. There are 6 people in this Jamboard, so I'm assuming everyone answered in this Jamboard. There's one other person who's supposed to be in the Jamboard who isn't, so like that's kind of disappointing. Like very disappointing, right? Okay, but anyways, so the answer, so basically we find the radius, which will be 8. So 16 divided by 2 is and you just do 8 squared, right? Pi, and then you find the answer to be 64 pi. Okay, so to the person who just joined, you are a bit late. I will put the Jamboard link in the chat. And okay, chat. Okay, this is not pulling up for me, so that's great. Okay. So again, here's the link to the Jamboard that we're on currently. So yeah. Okay, so 8 times 8 times pi is 64 pi. So this is correct. So you all get a gold star. So the next question is kind of hard, but it basically uses all the formulas that we have used so far. And much of the time, whenever you're doing like any competitive math thing, they're going to give you like a compound shape. So a shape that has like, you know, yeah. Okay, please don't move the image, like please don't enlarge the image so that part of it hangs off, because the whole point is so that we're able to see the whole thing.
Oh, I have a quick question right before I answer that. So, what does the here 1 second? I can't see the text. So, does the entire like the green circle and everything on top of it, like would you add all that up to count as how much of the white area is visible, or would you, or just say like the area of the green circle is part of the white?
So the area, so it's basically the visible white area. So whatever you can see that is white is what's included. So the blue will not be included. The orange and red will not be included. So it's stuff like that. Yeah. And also remember, it says visible green area. So do not include the whole area of the green circle. Like do not include what the area as the whole green circle would be, but rather what the area would be if what the area would be minus the parts on top of it that are not green. So yeah, and please do not move the image. That would be great if people could actually see the image and not just be like questioning if what they see is correct or not. So yeah. Okay, so this is going to take a little bit. So I am going to give you guys until 10:03 or 10:04, right? Because you guys will probably need that time. Remember, you are supposed to use pi and not 3.14 in your, like 3.14 multiplied by the value in your answer, right? Otherwise, you're going to get an approximation, and that's not what we want. So, yeah.
When we're trying to find out how much of the square is visible, can we convert pi to a number so that like
basically you are not supposed to use 3.14 for this because it's asking for the exact answer, and for
all right, so you just like subtract the pi, whatever you got for the area of the green circle.
Yeah.
From okay.
Yeah. Remember that you do not need to simplify your answer once you get it as like x plus y over a plus b, right? You do not have to simplify it once you get that. So yeah. So make sure you're actually solving this. And if you have a paper and pencil nearby, that would be great, just so you are actually able to do the problem and you aren't just like randomly guessing or like easily making mistakes, because that will be sad. So, okay, I did not see your question in the chat until just now. So you just put your answer on the slide and you find what it's asking for. So it's asking for the ratio of the visible green area to the visible white area in the frame. So you are not finding everything. You are not going to say that this is the area of the blue circle. And yeah. So make sure you're solving for what it's asking and not just for everything. Although you will use everything that you can get from this, right? You know, you don't want to like just give answers like that. And you know, you want to solve for what it's asking, not just for what you can find. Okay. Yeah, 24 is the diameter of the large green circle. 4 is the diameter of each of the blue circles. 4 is the diagonal length for both like horizontally and vertically of the diamond. And 12 is the diameter for the semicircle, for the red semicircle. And then the frame is a square with the dimensions of 30 by 30. So yeah. I'm just gonna edit the question. So okay. So the diagonals of the rhombus are equal to each other. So yeah. And again, make sure that so we know that you know the formulas, right? So I know that you know the formulas because we just went over them, right? However, make sure you aren't just plugging in the random numbers, right? You know, otherwise that's going to be wrong. Like for example, if I wanted to find the area of the green circle and I use 24 as the radius, that would be wrong because 24 is not the radius, 24 is the diameter. So again, make sure you are plugging in the right numbers. And to the person who joined like a few minutes ago, in the chat, if you have any questions, you can private message them to me because I know you weren't here when we went over some of the formulas. So yeah. And make sure you simplify your answers. So for example, you can combine the 144 pi minus 50 pi, right? You can do that. So make sure you're simplifying it. Otherwise, it's going to be wrong. Charles, make sure you edit your answer to simplify it. And it's not just going to be 28 pi to 756 pi or something like that, because you are subtracting areas from each other. Like for example, the area of the rhombus is not going to be in terms of pi, and therefore you're gonna at least have something in like the first part that is you know, yeah, that is not that is not a multiple of pi. Okay, so that the remember that the area of the visible white area is just going to be the white area minus what the area of the green circle would be if none of the shapes on top of it were there. So Charles, part of your answer needs editing, because I think you subtracted the thing you found in the first part from the area of the circle and from the area of the square frame, and that is not what you're supposed to do. Okay, so it's 10:04. However, I don't see very many answers. So, so basically, I'm gonna wait for like 2-3 more minutes. I'm gonna wait for more answers, and if more people don't answer by like 10:07, I'm probably gonna start explaining. And yeah. Remember, the visible white area is not going to be the whole area of the square, because the visible white area would be like the visible white area minus the visible green area minus the visible blue area minus the visible orange area minus the visible red area. However, because we know that all of these visible areas besides the green one are inside of the circle, that means we just need to find the area of the circle if there was nothing on top of it and subtract it from the whole area. Okay, so everyone make sure you put your answer on a sticky note or whatever it's called on the Jamboard. I want to know you're participating. I want you to participate. And yeah. This might be slightly harder than some of the questions that are asked on the AMC. However, this goes by the same principle of what many of the questions, are. So I know at least like 3 people who have not answered or working on it because they ask me questions. But I hope you are doing it right now. So I see 3 answers. Adib, we will explain it soon. I will explain it in like a minute or 2. So make sure you're paying attention, I guess, to the explanation because yeah. Okay. So I only see 3 answers still. However, please put your answer on the Jamboard. I want to see more answers. I want to know you guys are here and not just doing some other activity while you're in class. I don't want to like find out some of you guys are like playing video games or something, right? You're here to learn about AMC. Yeah. So I still only see 3 answers. It's okay if you're still working. And yeah. Okay. So I still only see. Okay, I see 4 answers now. Uh, well, I see 4 answers and then I don't know. So yeah. You probably should not be doing math in your head, like when you're doing like not complicated, but with many steps, because you will mess up. So yeah. Okay, so it's 10:08, so I shall explain. And no, you're gonna have to look at my screen, like look at my screen share to know what I'm typing or what I'm doing, because the Jamboard is a bit like slow for me, laggy. So yeah. Okay. So first, you have to find the visible green area. So the visible green area, so first we find the area of the green circle. And since the radius is 12, that means that the area of the green circle where there's nothing on it would be 144 pi, right? And we get the radius by doing 24 divided by 2 and then square, and then we square that value and multiply it by pi to find the area. Now we have to subtract the area of the two circles, of the green circles, or not green, of the blue circles. So we know the radius of both of them is 4, so we do 4 squared times 2, and we get 32 pi. So we subtract 32 pi, and then we have to find the area of this half circle down here, this red half circle, and the area, so the radius of that is 12 divided by 2, or 6. So we do 6 squared divided by 2, which is 18. So 18, so 144 minus, and then you can combine these to get minus 50 pi. And then 144 minus 50 pi is 94 pi, right? And then you have to subtract the area of the rhombus, right? So 4 times 4 divided by 2 is equal to 16 divided by 2, which is equal to 8. Then 94 pi minus 8 would be the numerator, right? As I see in many answers, like this one, like this one, and this one, right? You guys got the first part, right? Yeah. Okay, now for the second part, we have to find the visible white area. So the visible white area would just be what the white area would be, what the area of the square would be, minus what the area of the circle would be if we did not have anything on the green circle. So the area of the green circle, as we found, would have been 144 pi. There's nothing on top of it. So the area of this whole square would be 30 squared, or 900, and then we subtract the 144 pi, and we get 900 minus 144 pi, which is what I see in most answers for the second part. So there, 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 and there. Okay. I'm not very good at this. But basically, you find the ratio of these two. So 94 pi minus 8 over 900 minus 144 pi. However, you can still simplify it. You can divide like all terms by 2, and then you get 45, 46, 47 pi minus 4. 450 minus 72. So if you had simplified, you all would have gotten the correct minus 72 pi. Sorry. If you all had simplified, you would have gotten the correct answer, which would be 47 pi minus 4 over 450 minus 72 pi. However, your answers are unsimplified are still correct. However, just make sure when you're doing ratios, you actually are doing them like with like simplifying it. And yeah. Okay, so I'm going to clear all my drawings. Wait, does anyone have any questions about this? Because I know that a lot of people did not like do it correctly their first try, or they took a very long time to do it, or they did not answer. So in the chat or unmute, and please tell me if you have any questions, or if you don't, also in the chat type I have no questions or something to that extent. Just so I know everyone is here. If you don't have questions. So 2 people do not have questions. Okay. Yeah, simplification, sometimes it gets you. Okay, so I see 3 people have no questions. There are still 9 of you in this call. So 6 of you have not answered. I hope you're here and not like taking a nap, because that would be sad. This is not nap time. So I see 6 people have not answered. Do you or do you not have questions in the chat, or unmute and say if you do or don't have questions? The quicker you guys say if you do or don't have questions, the quicker we'll get to AMC problems and the better you're gonna get. So please, please, please in the chat type I do or I don't have any questions. I'm still not seeing anyone else in the chat. You can private message me if you do have a question, or you could, yeah. Okay, 4 people do not have a question. I'm still waiting for 5 of you. The quicker you guys answer what I just asked, like if you have any questions, the quicker we'll be able to do AMC problems, and there are a lot. So yeah. I still am wondering about if 5 of you do or don't have questions. Yeah, if you are not going to pay attention in class, then that's disappointing. Okay, 2 people, so that's 3 people, 2 people who have not answered yet. Okay, so we just finished with part 1 of the Jamboard. So if your internet is being very slow, we will come back to the Jamboard later. But yeah, you can put your answers in the chat when we come back to the Jamboard, and that'll be fun. Okay, but still 2 people are not really in attendance right now. That's disappointing. Like very disappointing. I thought you all would be here engaged, you know. But yeah. If no one who's attending really has any questions, then we shall return to the presentation. Okay, so sometimes the answer so the formula is s squared, so the side length squared, squared. Oh, can everyone hear me or oh, okay. I shall speak louder. Okay, so maybe it's my internet then. Okay, so for the formula of finding an equilateral triangle, you take the side length and square it and then multiply it by radical 3 and divide it by 4. This can also be done by finding half the side length, squaring that, and then multiplying it by radical 3. So we'll see an example on the next slide. Okay. So the area of an equilateral triangle example. So if we're given 5 as the side length of a triangle, we will see that the area is s squared, so 5 squared radical 3 divided by 4. And that would be equal to 25 radical 3 divided by 4, which would be equal to, which would be equal to 6.25 radical 3. So next class, so tomorrow's or the day after, day 2 or day 3, you will learn about a formula which basically helps prove why this is the reason for the formula, like why this formula works. And yeah.
So I didn't really get it. It's your equilateral triangle thing. So like the S is like the sides of the equilateral triangle, right?
Yeah.
Okay, so that'd be like 5 squared 15. And then the square root of oops. Yeah, and then you multiply it by the square root of 3 divided by 4.
No, it's the square root of 3 and then that whole thing divided by 4.
All right. Well, we have like a class how we like when we learn how to solve square roots. I mean, oh wait, no, we already had one. Never mind.
Yeah. Okay. Yeah, so the answer would be what's in bold, which could also be simplified to 6.25 radical 3. So a radical is just a square root Sometimes it can be used to refer to other roots, like a cube root, or a fourth root or a fifth root. However, you will rarely see anything beside the square root, and it's just a number. So like square root 3 or radical 3, when you multiply it by itself, so when you square it, you're just going to get what's in that square root. Well, you can find the decimal of it, but you can't really simplify it. And by simplify, I just meant you did the 25 divided by the 4 to get the 6.25 radical 3. But yeah. Okay, does anyone have any questions about this? Because it can seem a bit like hard or confusing when you first learn any formula. So if you have any questions, feel free to ask. And if not, I shall clear the drawings and move to the next slide, where there are 3 problems for you to solve. So in the chat, please type if you do or don't have any questions. And please make sure you're like paying attention throughout the class. Otherwise, this will be sad. Okay, 4 people have no questions. What about anyone else? Okay, 5 people have no questions. Okay, I'm gonna assume that no one has any questions. And if you have any questions, okay, 6 people don't have any questions. So these formulas, so this formula comes specifically from the formula we're going to learn next class, like you can prove it. So the formula we're going to learn next class is basically like it's called Heron's formula, and it helps you find the area of any triangle, and from that you can derive this formula by plugging in like the same side. Yeah. Okay. So practice problems for the area of an equilateral triangle. So find the area of an equilateral triangle with a perimeter of 12. Find the side length of an equilateral triangle with an area of radical 3, and find the area of a regular hexagon with a side length of 2. So remember that a regular hexagon basically just has is just 6 equilateral triangles put together. So yeah. And make sure you're putting the numbers for the question, because some people answer at different rates. So someone might solve 1 and 2 while someone else is still on number 1. So I don't want to get confused with which answer. And for the square root, you can, so just to like shorthand, you can just type SQRT, right, like when you're typing it right now. However, in real life, you'd want to use like the actual symbol. So yeah. Okay, so problem 1, everybody in the chat put your answer for number 1. Remember what the formula is, so you find half of the side length, so side length over 2, and then you square that, and then you multiply it by radical 3, which is the same, oh yeah, I can put the formula in the chat. So if S is equal to the side length, then the area is S over 2 squared square root 3. Wait, let me just. Or that can also be simplified to S squared square root 3 over 4. So yeah. And remember that the little like caret sign or whatever it's called, like the little upside down, or not upside down, the little triangle like thing without one side, that just means to the power of. So if I did S and then that symbol, like 3, that would just mean S to the power of 3. Or if I did S and that symbol 2, that would be S to the power of 2. Okay, make sure you're putting the number for the questions, because I see some people have not put the number to the question they're answering. Okay. So for number 1, I'm getting a lot of 6.25 square root 3. Wait. Okay. I'm sorry. No, I got 4 square root 3. I'm sorry, that was someone else for a previous problem. Okay. Then, yeah. Okay, so would you guys rather I let you solve all these problems, or would you rather we went one at a time and everyone puts the answer for like number one, and then I explain it, and then we do that for each of the problems, or would you rather I let you solve all of them? Okay. So I see 2 yeses, and I'm assuming that means that you'd rather I do the first thing where we go one problem at a time. So for number 1, since this is the formula, s over 2 squared radical 3, right? So the perimeter is 12, right? So since 3 of the sides are equal to each other, that means each of the side lengths is 4, right? So we just plug 4 into this equation, and we get 4 over 2, which is 2 squared radical 3, right? So this would be 4 radical 3. So that would be the area of the first one. So make sure that you aren't like multiplying it by the decimal value of radical 3, because right now we're just doing the exact value and not the, uh, approximate value. So use like radical 3 or square root 3 in your answer. So for number 2, I think I've seen one answer. Yeah, I think I've only seen one answer. So yeah. Make sure you are putting your answer in the chat. Okay, so I saw 2 4s, and then I saw another answer. Make sure you're answering the question. Make sure you're using this formula over here. And remember that S just stands for the side length. So yeah. And remember, so this formula is side length over 2 squared is equal to radical 3 equals area. So I saw an answer saying 2 for number 2. I think someone said 1/4 for number 2. And then I saw another answer as 2 for number 2.
The 1.7 and 1/4 were just accidental.
Oh, okay, that's okay. So I shall start explaining number 2 if everyone's okay with that. Okay, so the area, right, we plug in the area is radical 3. So we get radical 3, or square root 3, is equal to square root 3 times s over 2, and then that whole thing squared, right? So basically, we can divide both sides by square root 3, right? Because both of them, if we divide by square root 3, we just get 1 on one side, and then we get s over 2 squared on the other side, right? So when we divide by square root 3, we get 1 on the right side. And then on the left side, let's open this up. So this goes to s squared over 4 is equal to 1. And then we multiply both sides by 4, and then we get s squared is equal to 4. And then we find the square root of both sides. Technically, s can be plus or minus 2. However, because we're finding the length of something, it will always be positive. So that means that s is equal to 2. So the side length of this is 2. So I saw a lot of people got it correct. However, a lot of people got it incorrect. So in the chat, please, like around half and half got it correct or incorrect. So in the chat, please, like you can private message me, or you can just put it in the general chat. Please tell me why you got it wrong if you got it wrong. Like it could be a silly mistake. It could be you accidentally plugged in the wrong thing. You could have plugged it into the wrong place, whatever, right? But just please. Oh, okay. Yeah. Okay. Sometimes when you do the math, you accidentally mess up, and that's okay. Like after a few steps you mess up, that's okay. So remember when you ever have like x squared equals something, you just have to find the square root of both sides, or something like that, right? You'd find the square root of both sides, and when you find the square root of both sides, you're going to get a positive or a negative, because like -2 times -2 is equal to -4, and the negatives cancel out and they get 4, right? Or you could get 2, which multiplies, like when you square it, you get 4. So make sure that you know that you can get both a positive or a negative, square root when you're finding the square root of both sides. Just make sure you know which one makes more sense given the problem. For example, if it's asking you for distance, it's like 100% of the time like going to be positive. Except for that one, like they could perhaps ask you like compared to like a starting place. Where is it? So technically that is an actual formula where you multiply the area of the equilateral triangle 6 times. So you would get s. So technically the area of a regular hexagon is the actual formula for that would be 6 multiplied by the area of a equilateral triangle. So that would be s squared 3s squared over 2 radical 3, which would be the area of a hexagon, right? But that's only for a regular hexagon. There are many other, like, so whenever you get an irregular shape, like an irregular hexagon or something, you usually want to divide it into triangles because you can easily find the area of a triangle. But there's no actual formula for a non-regular, for an irregular hexagon, if that answers your question. And again, make sure you aren't plugging in the wrong thing. I got at least 2 people telling me that they plugged in the wrong thing. You know, it can happen a lot of the time, but make sure you're just like checking your work when you're doing it. Like in the MC, perhaps you might not get enough time to check your work. However, when you're doing it like practicing, check your work just so that you know if you're right or not. So in the chat, type your answer for number 3. And again, if you do not know how to solve it or something like that, actually, I don't know if I said this previously, but if you don't know how to solve it, then put the answer, then in the chat, tell me I don't know how to solve it. You can private message that to me or something, right? But it's better to know that you're here, but you just don't know how to solve something than to know you are not, than to not know if you're there or not, right? You know? So yeah. Okay, remember that the irregular hexagon is just 6. It's just 6 equilateral triangles next to each other, you know? So, yeah. Okay, so I got a 6 radical 3 for number 3. I got 6 radical 2 for number 3. And remember, if you are having an equation with a radical 3 in it, and it does not have a radical 3 in the problem, you're probably going to get radical 3 somewhere in your answer. Yeah, okay, you fixed it. So 6 radical 3 for 2 people. I don't think I got any other answers for number 3. I shall check my chat. Okay, so I did not get any other answers for number 3, as far as I know. Okay, it's okay if you need some time. I can give you some time, yeah, to solve it. Yeah. So remember that, as I've stated twice, I think, a regular hexagon is just 3 equilateral triangles put together with the side length equal to the side length of the regular hexagon. I can draw it out, although I can't say that my drawing skills are good. I mean, I can say that my drawing skills are bad. But yeah. So here is the regular hexagon. If I can draw. Okay, let's just, yeah. Okay, so pretend that this is a regular hexagon, right? Then the 3 or the 6 triangles would be, if I can get it. Yeah, you can use the restroom. You don't have to ask. However, yeah. Okay, so these would be the 6 equilateral triangles. So yeah. So that would mean that the side length of the equilateral triangle would also be the side length of the hexagon. And yeah, so I got 3 answers, I think. Anyone else going to solve it, or should I start explaining? Okay, so I know that one person at least needed more time, and that's okay. However, we do have other things to cover in this class, so I am going to start explaining this problem because there are a lot of AMC problems and I want to get to them, you know? So find the area of a regular hexagon with side length 2. So as I showed in this diagram over here, a side length of 2 would mean that it would have, that it would be just 6 triangles with a side length of 2, right? So the area of an equilateral triangle with a side length of 2 would be 2 over 2 squared radical 3. 2 over 2 is just 1, meaning that we get 1 radical 3, or just radical 3, right? And then we multiply this by 6 because there's 6 triangles. So we get 6 radical 3 as our answer. So everyone who typed their answer in the chat got it correct, so good job. However, a lot of people did not answer. I'm going to assume that was because you needed more time and not because you didn't know how to solve it. So in the chat, if you did not know how to solve it, or you do not understand anymore, please tell me. So yeah, the hexagon formula is basically just what I did. However, it's just 6. It's just 6 times this. And okay, so 2 people said they either needed more time or they understand now, so that's good. And yeah, I shall clear all my drawings. And okay, so the area of a regular n-gon. So an n-gon is basically a shape with n sides, and a regular polygon is it is a polygon with all equal sides and all equal angle measures. So how we find the area of it is 1/2 of the perimeter multiplied by the apothem. So the apothem is the distance between the center of the polygon to the side, where they form a right angle, as shown in this diagram over here, right? And the reason it's half the perimeter times the apothem is, okay, let me just quickly draw. Okay, so as we can see, if we make this into like triangles, we get this. So sorry, it's just gonna take me a sec to draw these triangles out. Okay, yeah. When we divide it into triangles, we can see that, so we know that the side length is equal to each other. We know that this side length is, let's just name it question mark, right? And we know all side lengths are named question mark, right? So then the perimeter of this, which is a pentagon, would be 5 question mark, right? Wait, no, sorry, that's getting ahead of myself. So the area of each of these triangles would be the height or the apothem, right? We can name that A because apothem starts with A. A multiplied by the base, which we named question mark, divided by 2, right? And there are, so the area of each of the individual triangles would be A question mark over 2, right? And then we have to multiply this by the number of triangles that there are in this polygon, right? In this regular polygon. Well, the number of triangles in any polygon will always be equal to the number of sides, right? When we're dividing it from the center. So we multiply it by the number of sides, which is n, because it's an n-gon, right? So we get n times a times question mark over 2, right? So how do we get this perimeter times apothem times 1/2 equation? So basically what we do is n times question mark. So if there are n question marks, that's just the perimeter, right? Because each side is question mark and there are n sides. So n times question mark is the perimeter, or p, right? P multiplied by a, or the apothem, over 2 would be equal to the area of the regular n-gon. So that means that the area of any regular polygon is 1/2 perimeter times apothem. So does everyone understand that, or are there any questions? In the chat, type if you do or don't have any questions. Okay, I see 2 people with no questions. You can private message me if you do have a question, if you don't feel comfortable like saying that, in the public chat. So I see 5 people do not have questions. And I am going to assume that means no one has any questions. So clear all drawings. And then we are going to move on. So this slide just explains it. Okay, and then also we're going to figure out the area of an abnormal shape. So many times you'll be given a random shape that is a combination of multiple shapes. And you should try to combine the area formulas you need to solve, you learn to solve them. So try this example. So previously we also did an abnormal shape formula. So an abnormal area of, the area of an abnormal shape, right? So, so for this question, Janaki won a digital art competition by creating the following work. If the dimensions are given, find how much of the visible area of the image is not red. So when I say visible area of the image, I mean this brown part plus this so the visible area would be the brown part plus the red part plus the white part, right? So find out how much of that visible area is not red. So, so use the formulas that you know. So you're going to need to know how to find the area of half a circle, which is also a sector of a circle. It's just 1/2 of a circle. So yeah, and then you're going to need to know how to find the area of a circle, which is pi r squared. And then you're also going to need to know how to find the area of a triangle, so base times height. So solve it, and I will give you guys until 10:42 or 10:43. After this, after we cover abnormal shapes, we will cover perimeter, and then we will have a break, or actually between area and perimeter, we shall have a break. And then we will continue with perimeter and then go to the AMC problems if we have time. Okay. So I see one answer in the chat. So the question is asking for how much of the visible area is not red. So the visible area is just the brown part plus the red part plus the white part. So find how much of that is not red. So yeah. And
Is that circle with the 2 on it, is that part of it?
no, that the dimensions are not part of the image. Okay, so the little semicircle is not supposed to be red. So yeah. And make sure you're not finding the visible area, but finding out how much of it is not red. Okay, the red part is like that dark red thing, half circle. Yeah, the semicircle is red. So yeah. Yeah, so I saw, okay, again, remember, do not plug in pi, like for 3.14, but express your exact answer. So like 10 minus pi or something like that. That is not the correct answer, the answer I just gave. However, please express it in terms of pi, and not in like decimal format. Yeah. And I see 2 people have solved for the visible area instead of how much of the visible area is not red. Remember, you're going to need to subtract something to find out how much of it is not red. Okay, so I think that some of you are, yeah, okay. So I've seen one correct answer. So so some of you have typed your answer as if 4 was the radius instead of the diameter of the actual circle. Make sure that that is not what you're doing. And remember to make sure that you're including the white circle in the area, in the total visible area when you're finding how much of the total visible area is not red. Okay, make sure you are including how much of the, make sure you're including the white circle in the visible area.
Oh, the white circle is part of it? Oh.
The white circle is part of the visible area. However, the 2 and the dimension, like the arrows, are not included in what part of it is red or not. So, yeah. Okay, so there are some other examples of like, not examples, but other problems which you can solve um, uh, in the slides for area of abnormal shapes. And basically it will, there's another problem which we will not be covering, but you can cover on your own time because I want to get to the AMC problems. So yeah. Okay, so I've seen at least 3 correct answers, so I'm just going to show the explanation. So this is the shape, right? So we take the area of the triangle, which would be 30, and then we take the area of the half circle, which would be 2 pi, and then we take the area of the white circle, which would be pi, and then what we do is we subtract the red circle from the triangle, um, and then we add the white area, right? So 30 is the area of the triangle, then the white area is pi, and then the maroon part or red part or whatever is 2 pi. So we get 30 minus 2 pi plus pi, which is equal to 30 minus pi, which gives us our answer. So I saw a lot of people got it correct on the second try. So good job for correcting yourself, but make sure you know why you got it wrong. I think many people got it wrong because they were only solving for the visible area. So yeah, and then we'd get our answer of 30 minus pi. So we shall be having our break right now because 1 hour and something minutes have passed. So yeah, and okay. Okay, so perimeter. So the perimeter is the sum of all side lengths of a polygon, and circles have something else called circumference, which is just the perimeter, basically. So the perimeter of a square is just 4 multiplied by the side lengths, and this is because all side lengths are equal, so we just multiply the side length, one of the side length, by 4, and we get the perimeter. The perimeter of a rectangle is the length plus the width times 2 because there are 2 lengths and 2 widths. So when you add them together, you get that. And then for a regular n-gon or a polygon with n sides that are equal, you get the number of sides multiplied by the length of each side. And then for circumference, it's just 2 pi r or d pi. So d is just the diameter and r is just the radius. So yeah. So also, it's very hard to get that formula without doing without sorry. It's very hard to get the circumference formula without like if you do not memorize it or if you do not like remember it. So you're going to need to like keep it in mind whenever you do it. So like you cannot like find the circumference just by hand like normally like the formula easily. So you're gonna need to memorize that formula. So
Yeah, there's like
the wait, you
there's
can
like
you
a
can speak.
special formula for the circumference, right?
Yeah, the circumference is 2 pi r or pi d, where d would be the diameter or r would be the radius. So yeah. Okay, so these are some problems for you to solve. I think we'll do the first three, and if we get time, we'll do the next three. However, I really want to get to the AMC problems because they are really great. You know, AMC is the whole point of this course. So I want to get to the AMC problems because there are a lot. So for number one, a rectangle has a length of 9 and a width of 6. Find the perimeter. So in the chat, type your answer for that. And remember, perimeter is just the sum of all the sides. Yeah. So I have one answer. Perimeter is easy compared to area. So yeah, you guys should be able to solve this quickly. I am waiting on more answers. So once we get to 5 answers, I will start explaining a problem. So there are 2 answers so far, so 3 more to go. Okay, 2 more to go. So do not, okay, yeah, you can solve next problems. However, your answers might get lost in the chat. So yeah. Okay, I got 4 answers so far. 1, 2, 3. Okay, no, I got 3 answers so far. Please in the chat type your answers so we can quickly get to the AMC problems. Otherwise, it's going to be pretty sad. And yeah. Oh, and if anyone is away from their computer, make sure you're back. You know, the break is over.
If someone was away from their computer, they wouldn't be able to hear you.
Right, I know, but if they're like in the vicinity or something, you know, perhaps they could. Yeah. I mean, that's kind of illogical, but oh well. Okay, so I've gotten 5 answers so far. So the length is 9 and the width is 6. So remember that the perimeter is just the sum of the sides. So there are 2 lengths, so that would mean we'd get 18. So 9 times 2. And then there are 2 widths. So 2 times 6 is 12. 18 plus 12 is equal to 30. Okay, so you all got it correct. So good job. So we're only going to do the first 3. So like, yeah. So I got 1 answer, or 2 answers, 3 answers, 4 answers. Okay, I got 4 answers for number 2. I just need 1 more person, and then we can, you know, do it. Okay, the perimeter of a pentagon is just 5 multiplied by the side length. Okay, yeah, it's okay if you put all the answers, but we're only gonna do 1 to 3. So yeah. The area of a pentagon is just the apothem, so the distance from the center to the side length where it forms a 90-degree angle, multiplied by the perimeter divided by 2. So yeah. Okay, so I'm just gonna start explaining this. So if the area of a square is 36 square centimeters, that means that the side length would be 6, right? Because square root of 36 would be 6. So then the perimeter would be 6 times 4, which is equal to 24, right? So 6 times 4 is equal to 24. Then the perimeter is 24. So yeah, I think that's an answer I saw. Yeah, that was what I saw for most people, so yay. And again, if you have any questions in the chat, please type I have questions because I cannot mind read. Yeah, okay, so I've gotten 2 answers so far for number 3. I mean, who can mind read, but like, yeah. Okay, so I've gotten 2 answers for number 3. Make sure you're putting in your answer for number 3.
Number 3, as in the perimeter of the square yard is 52 feet, right?
Yeah. Okay, I got 3 answers for number 3. 4 answers. 5 answers, 6 answers. Okay, we can start explaining. So the perimeter of a square yard is 52 feet. So 52, so it's square. So 4 of the sides are equal to each other. So the side length of the yard would just be 52 divided by 4 because all the 4 sides are equal, right? And all we're looking for is the side length. So 52 divided by 4 is 13. So that means the side length of the square yard is 13. So yeah. And I think that's what I saw for most people. But yeah, okay, so as I said earlier, we're only going to do the first 3 problems, not the second 3, because I want to get to the AMC questions, right? So yeah, sorry if you solved all the problems. Yeah, okay. Okay, oops. Okay,
If you
yeah.
saw that the break video, the guy's face who made the video was hilarious.
Yeah. Okay, so AMC 8 problems. So there are 23 of them. So yeah. Basically, so this is problem number 1. So 3 identical rectangles are put together to form ABCD as shown in the figure below. Given the length of the shorter side of each of the smaller rectangles is 5 feet, what is the area in square feet of rectangle ABCD? So in the chat, type your answer. And remember, it's always great to have a drawing whenever you're working with geometry. Like just draw out the diagram, or if you have the diagram printed out, you can draw on that. If you don't have paper, you can open up like a Jamboard, like go to jamboard.google.com, I think, and then you can open up your own Jamboard and then do the math there. Please do not do it in the Jamboard that was shared with you all because that'll be a mess. So I got 150 square feet from 2 people. Okay. So yeah, I got 150 square feet from 2 people. Make sure you're actually doing the math, yeah. So we shall wait for till 11:03. So yeah. Make sure you type your answer in the chat again. I still only see 2 answers. Make sure you are actually answering. Make sure. Okay. So I got 1 person who got 50 square feet. Make sure that you're actually like finding the area of ABCD and not one of the individual rectangles. So I still only have 3 answers, and it's 11:03. So I'm going to assume that you all are still working, or something. And remember, in the chat, please stay on topic. I don't want to like lose an answer in the chat because people are, typing random things. So basically we know that this is 5, right? And we also know that the other, the side below it is also 5. So that means that this whole magenta thing is 10. So we know that the left part, so the long side of the rectangle is 10. And then we know that the short side of like one of the smaller 3 rectangles is 5. So that means that this orange side is 15. So we do 15 multiplied by 10, and then we get 150 as our answer. So 10 times 15 is 115, 150, and that is the area of rectangle ABCD. Does anyone have any questions? Okay, so if no one has any questions, I am going to move on. And remember, if your question is long, you can just raise your hand and I can call on you, or you can just unmute and ask it. Okay, so find the area of, oh God, okay. Find the area of the shaded region. So you will need to find the area of the shaded regions. You will be using the area of a triangle and the area of a rectangle in this. So this is not a really hard problem, but it has many steps in it. And at first, it might be a bit hard to figure out how you're going to even start, right? However, if you do not know how to solve this, in the chat, you can always like message me saying, I do not know how to solve this, or I need help, or something along those lines. And, you know, if you're stuck on one step, I can help you. And if you're stuck on the whole thing, just wait for the explanation. So yeah. Okay, so I'll give you guys until 11:08. It's currently 11:05. Also, my internet is kind of unstable. So if I cut out, please tell me if I do, especially while I'm explaining the problem. Okay, so see if you're able to divide. Okay, so when it says 4, it means that that's the length of this part of the side. So, so the whole length of that one side would be 4 plus 1. So yeah, no problem. And remember that a lot of the times AMC problems use basic concepts, but you have to apply them in ways that perhaps you either did not think of, or you have to do a lot of steps. And that's what makes many AMC problems hard. It's not because they use like some complex like calculus or something, but because they use a basic concept and you do not know how to apply it because you have never really paid attention to that basic concept, you know? Or you do not really think you can apply anything. Like, you know, at first it looks complex, but you can just easily use some concept that you have heard of, you know, or that you know of. So it's 11:07, and I see only one answer. That is a guess. So yeah. And remember that the area of the rectangle would be 40, so it can't be 48. Yeah. Okay, so I see 0 answers. Make sure your answer is reasonable. Like, just by the looks of it, you can tell that it's probably not half of the rectangle's area, right? You know, or it's probably slightly less than half of the rectangle's area. So, or just less than half the rectangle's area, right? So using like logic, you should be able to figure out, oh, it's probably not going to be in this range, you know? And if you get an answer in that range, which you say it won't be in, then like, you'll know you did something wrong and you'll know to check your work. Okay, so I have seen 2 answers. They are very close to the actual answer. However, they are not correct. Do you guys want me to explain the problem or do you guys want to figure it out?
Yes, let's explain.
Okay. So basically, we know that this height, so basically this is in the middle of the triangle, of the rectangle, right? So the height of this would be 4 plus 1 divided by 2, because that would be half of the side length, right? That would be half of the shorter side length, right? This would be the center of the rectangle. So that would mean that the height of this would be 2.5. And then that would mean that this is 4, because 7 plus 1 divided by 2 is 4, right? And since this is the center. So we can divide this into two triangles, into two pairs of triangles, right? So so the orange rectangles, so area of each of the orange rectangles would be equal to the height of that rectangle, of the triangle multiplied by the base. So we know that the base divided by 2, and then multiplied by 2, because there are two triangles, right? So we do 4 times 1 divided by 2, and we get 2 is the area of each orange triangle, and then 2 multiplied by 2 triangles is equal to 4, right? And then we see that these two are blue triangles, right? And we see that the area of each of those triangles would be the base times the height, which is 2.5 times 1 divided by 2. Base times height divided by 2 multiplied by 2, because there are two triangles. So we get 1.25 times 2, which is 2.5. So 4 plus 2.5 is equal to 6.5, which means that the area of the shaded region is equal to 6.5. So does anyone have any questions about that? I see that many people have typed O in the chat, so I'm assuming that means that it was somewhat obvious.
Can I have like 1 minute so that I can like look at what's on the Jamboard or not Google Doc?
Yeah, that's okay. Okay. And also note that these slides will be available to you after class. So if you ever want to, like, I don't know, take a screenshot or like solve something by yourself, you can do it. Also, there are 23 problems. We are only on problem 2, and we only have 20 minutes of class. I divided by 2 because it's the area of the triangle. It's half of base times height. And then since there are two triangles, we later multiply down there.
Well, if there are two triangles, what's like the point of dividing by 2, since you just have to multiply it by 2 at the end of the day?
Right, but like it's like still it's better to do like more steps, and then like perhaps have some of them be redundant and be correct, rather than like forget to do a step or something like that. So yeah.
Why is like the area of the blue triangle different from the area of the orange triangle? Aren't they like the same amount, or?
No. Okay, so the base times the height. So the height of the blue triangle would be 2.5, right? Because that's the green length. And the base of it would be 1. However,
I see. I didn't notice how the like yellow triangle was tilted. It's
yeah,
they both have different bases.
yeah. They both have different bases or different heights, and that means that they have different areas. So yeah. Okay. Point O is the center of the regular octagon ABCDEFGH, and X is the midpoint of AB. What is the area? What fraction of the area of the octagon is shaded? This is probably easier than the previous question. So yeah. I shall give you guys until 11:14 or 13. And make sure you type your answer in the chat for this problem. Okay, I've gotten one answer, 7/16. Two answers, 7/16. 3 answers, 7/16. Okay, so I'm going to, okay, 4 answers, 7/16. One more person answer and we'll be able to look at the explanation.
It's only like every single time. Me, Charles, some person named Nikita, and that's pretty much everyone who actually ends up answering.
I mean, many people private message me with the answers, so yeah, that's what happened. Okay, I have gotten one more answer, so we can explain. So we can just divide it into triangles, right? 8 equal triangles, because it's an octagon. Oh, got it. Right, and then because we see that BXO, right? It's half of a triangle. We get 3.5 out of 8 total triangles, and we don't want to leave it in 3.5. Like we don't want to leave any of it in decimal. So we multiply both the numerator and denominator by 2, and we get 7/16. And then, yeah, that's the fraction of the area that is shaded in. So next problem. Rectangle ABCD has sides CD equals 3, DA equals 5, and DA equals 5. The circle of radius 1 is centered at A, and a circle with radius 2 is centered at B, and a circle with radius 3 is centered at C. Sorry, I'll need to correct that. What is the area inside the rectangle outside the circles? Yeah. And remember that the radius of a circle will always be equal to the radius of the circle. I know that seems like a dumb thing to point out to some of you, but the radius in a circle will never change. If it's like, so for example, circle C has a radius of 3. So the radius, no matter where the end point is, will always be 3, right? Where no matter where the end point is on the circle, it will always be 3. So, yeah.
How are we going to like convert the pi? The area of a circle is pi. So.
You can just type pi in your answer. Yeah. Okay, so I am like 99.999% sure we will not be able to get to all problems today, and we will not be able to get to the fun activity, right? The fun activity was going to be like a competition-like thing, but it required like 40 minutes to complete. So, and it required many more people. So, yeah, that's kind of sad. However, we will try to complete as many AMC problems as we can. And after class, you can look at these problems so you can actually do it. Okay, I got an answer with 15 minus 4 pi. That is close, but it's not correct. And 15 minus 14 pi would be incorrect because pi is greater than 3, and 15 minus 14 times 3 would be negative, and yeah, that would be wrong. Remember to use the area of the sector of a circle, which would be, the formula for the area of the sector of the circle. And I shall just write it out, right? So say this is a circle, and we are taking the sector of this, right? And right, say this is the sector of x, right? And the radius is r. Then we do x over 360 pi r squared, pi r squared to find the area of a sector of a circle. Okay, so I've gotten one answer. Okay, I see 2 answers. 3 answers. I'm waiting for another answer. Yeah, I saw that you put your answer first. Right. So I'm waiting for another answer. And yeah, or until 11:20. Okay, I've gotten 4 answers so far. Okay, so basically what we have to do, okay, let me just, yeah. Okay, I'm just gonna clear all my drawings. So basically we know that this is 3, right? Because the radius of a circle is equal to the radius of that same circle. And then this is 2 because 5 minus 3 is equal to 2, right? And it's a rectangle. And then this is equal to 1 because 3 minus 2 is equal to 1. And then the area of each of these sectors is 1/4 times 2 squared pi, which equals pi for the light blue, and then pi over 4 for like the, I don't know, whatever color that is, blue, yeah, for that. And then 1/4 3 squared pi is 9/4 pi, so that would be the orange one. So when we do the math, we get that the area of the parts that are inside the rectangle would be 10/4 pi plus pi, which is 14 pi over 4, which is 7 pi over 2, right? So 3.5 pi. And then we have to subtract that from the area of the rectangle, which would be 15. So 15 minus 3.5 pi would be our answer. Yeah, so that would be our answer. I mean, it explained it. Okay, in the diagram, all angles are right angles and the length of the sides are given in centimeters. Note the diagram is not drawn to scale. What is the length of x in centimeters? So if you're in the number theory class, you will know that we said that usually like 99% of the time, the diagrams are drawn to scale. So like make sure you keep that in mind, because they use like, oh, they do draw it to scale like 99.99% of the time because they use like online, like, you know. Oh, sorry, it has 2 ins. Oh, well. Oh, so this is scaled, right? You know, like you can tell just by looking at it that x will be less than 6. It just says that this diagram is not drawn to scale because they just want you to actually do the math and not take ruler out and, like, you know, yeah. And so I see 1 answer. Okay, 2 answers. We shall wait for 2 more, perhaps, or 1 more. And as I said earlier, there are like 20 problems. So as I said earlier, there are like 25 problems. So there are 20-ish more that we probably will not get to in this class. So like you can look at these after class. So here's the thing. If you actually do the math, you'll get the answer and you'll know the answer. So like, don't just go off of your feelings. Like, it's good to see like, oh, it can't be like, it's probably less than 6, right? However, don't use that to be like, oh, it looks like it's like, you know, 4.56 of that, you know. Don't be like that, you know. Actually do the math and then use like what you can visually see to like figure out if your answer is reasonable. So yeah, right. It is probably like off by like 0.1 or something, so they're like, it's not to scale. They say that the diagram is not drawn to scale, so you don't just take out your ruler and go like, oh, I can measure this. So yeah. So I've gotten another answer. So yeah. So the height of the figure is 6 plus 1 plus 2 plus 1. So we can see that by 6 plus 1 plus 2 plus 1, right? And so the height is also equal to x plus 2 plus 1 plus 1 plus 1. So that is equal to, so we can set up an equation. Basically what it is 6 plus 1 plus 2 plus 1 equals x plus 2 plus 1 plus 1 plus 1, right? And then when we like simplify it, it is just 10 equals x plus 5, and we subtract 5 from both sides and we get 5 is equal to x. Okay, so yeah. I mean, you could, okay. Well, I mean, yeah, you could do 6 minus 1, but like you don't actually explicitly get that anywhere.
Well, you could 6, even if it's not scaled, 6 minus 1 makes sense, since if you look at the values, with 6, the same height is like, so if you go up by 2, wait, I don't know how to explain this, never mind.
Okay. So next question. I think that this might be the last question we'll be able to do today. Like AMC question before we go over the homework. So two circles share the same center, have a radii of 10 meters and 20 meters. An aardvark runs along the path shown, starting at A and ending at K. How many meters does the aardvark run? That's how you spell aardvark, by the way. Yeah, radii is just plural of radius. So yeah. So it's 11:25 right now, so I'll give you guys until like 11:28. So this is just basically perimeter. But I'll give you until 11:28, and then we'll just go over like I'll put the homework in the chat, and then yeah.
Okay, I just had a quick question. When we meant go over homework, we haven't gotten any homework for the geometry unit yet. So
I know. I'm going to give you guys the homework for today. So like, yeah, just so you guys have access to it immediately after class, rather than having to like wait for me to post it in the Google Classroom. So yeah. Okay, so remember that this is just basically perimeter, but like of parts of the circle, you know? So I see no answers so far. So I am assuming that means you guys are still working. Please make sure you're working. I saw someone in the chat said that they did not understand the question, but I explained it. However, I didn't ask if you had questions at that point in time. So I don't know if you were paying attention in class or if you just wanted to say that, but yeah. 10 pi, okay. So whatever answer you get, simplify it. That would be great, So yeah. So someone said 60 pi. However, part of it is not going to be a multiple of pi. So like, you want to, you're going to have a part that is not just a multiple.
I have another question. Do all like the arrows like A thing are going around the small circle? Is that part of the path, or does the aardvark just not go straight through?
That is part of the path. So it's
okay.
Yeah, round.
This aardvark has 10 IQ.
Yeah, it could just go from A to K directly, but oh. Again, make sure you simplify your answer. Otherwise, yeah. Okay, so I've gotten like 4 answers, I think. No, 3 answers. So, and one of them is not simplified, so make sure you simplify your answers. You know, that would be great if you would. And if you wouldn't, then there's not going to be an answer choice that has your answer. So, yeah. I don't think you added everything together, Nikita. Because I see at least like 2 2.5s, 1 5, and a 10 in your non-simplified. And that should add up to more than 10. Or wait, am I reading that wrong? Okay, maybe you meant to say 20 pi plus 10. Okay. So I have 3 answers so far. It's 11:29, so I shall start explaining. So, oh god. Okay. So basically this, so this is 20, right? So from A to the center, this is 20. And then this is 10. So that means that when we're going from A to this point over here, we're doing 1/4 of the circumference of the circle. So the radius of the circle is 20. So that means that circumference is 20 times 2 pi, which is equal to 40 pi. And then we divide it by 4 because it's only 1/4. So we get 10 pi over here, right? And then we travel from this distance, from this point to this point, right? So that means that we are going 20 minus 10, or 10 units, right? And then we go from here to here, which is equal to the circumference of this smaller circle divided by 4. The diameter of the circle is 20, so we divide it by the diameter. Let me start off. The radius of this is 10, so that means that the circumference is 10 times 2 pi, which is 20 pi. And then we divide it by 4 because it's 1/4, and then we get 5 pi, right? And then we go this diameter of this circle, of the smaller circle, and we get 20, right? Because it's just 10 times 2. And then we get this right over here is 1/4 of 10, it's 1/4 of the circumference, which is 10 times 2 pi, which is 20 pi divided by 4, right? Which is equal to 5 pi again. And then the aardvark goes from this point to K, and that means that they're going 10, right? So we add these together and we get 10 pi plus 10 plus 5 pi plus 20 plus 5 pi plus 10. And then we add like terms and we get 20 pi plus 40. So our answer is 20 pi plus 40. So yeah. Okay, it's 11:32, so let me just quickly share the homework with you guys. Let me just. Oh, and also you guys will be able to look at like the problems in the fun activity, so you can do it yourself. So copy link, and then in the chat I shall everyone in the meeting. Okay, so here you can see the homework, and I shall post it in the Google Classroom, and I shall stop the recording. If anyone has any questions, feel free to ask me.